Hello everybody, and welcome back to the CCNA routing and switching video series brought to you by ABY Design and Tech. Now, we are going to finish off this section of network devices by actually having a look at what these devices physically look like. So, up until this point, we've looked at the function of these devices, what they do in our networks, etc. We've seen icons, so the icons I've been showing in the diagrams that I've been showing you guys. These are the icons used in books to identify these devices, so that when you read a book, when you look at a diagram, it's easy to distinguish this is what an access point looks like, this is the icon for an access point, this is the icon for a firewall, icon for a switch. However, it's going to be so much more beneficial to you guys if you can actually see what these devices actually look like in real life. Now obviously, I don't have a camera with me, so I can't show you what my lab looks like. However, I'm going to now go through and show you pictures of what these devices look like, so you can actually know what these devices look like in the real world. You can know what to actually expect. As an example, a router isn't round. Okay, so let's jump straight in. So let's start with the switch, the first device that we covered. So a switch just looks like a square box. Okay, and with the switch, what we have here, we have what we call our Ethernet ports. So Ethernet ports, those are the ports which allow us to connect our devices, our laptops, our computers, our phones, etc. into the switch. So we would run a cable, what's called an Ethernet cable, a network cable, from our device, and it goes into one of these ports on the switch. Now, the switch will learn what device it can reach out of each of these ports. Even if it's another switch, it'll know, okay, I can reach another switch out of this port. And it will know, okay, if I can reach another switch out of this port, what devices can I reach out of this port, etc. So these are what we call our Ethernet ports, our network ports. Now, over here, what we have here is we actually have more network ports, or these two holes here allow us to essentially put in what we call SFP modules. So what SFP modules are, they're fiber modules allowing us to run fiber cabling. More about fiber cabling in a moment. So like I said, is that we've got our switch, and these switches that we have got network ports, Ethernet ports, which allow us to connect our devices into the switches. This is what we are going. This is a type of cabling we are going to run between our laptop, our desktop computer, our phone, between our computer, our network device, and our home user devices. This is what we call an Ethernet cable. Now there are different categories, different standards of Ethernet cabling. We will get into those when we look at Ethernet in depth. So we've got Cat5, I think, which runs up to 100 megabits per second, Cat5e, which is 1 gig. We've got Cat6, which can run at faster speeds. So I think that can run up to like 10 gig or something. And then we've got Cat6a, etc. Fiber cabling. So what's fiber cabling? So fiber cabling, again, is another type of cabling allowing us to connect devices in an Ethernet-based network. Now I hear you say, what is the difference between Ethernet and fiber? Now the main difference between Ethernet and fiber is the distance. So Ethernet cabling, that allows us to connect our devices together as long as those devices are less than or up to 100 meters apart. So as an example, if we have a network switch and we wanted to connect our, let's say, our laptop to our network switch, to our switch, we could do that fine with the Ethernet cable as long as that laptop is 100 meters or less in distance away from our switch. Now, if we have a device and we want to connect those devices together, and those devices are more than 100 meters away, we can't use Ethernet cabling. Essentially, Ethernet cabling only has a distance of 100 meters. We can instead use fiber cabling. Now, I hear you ask yourselves, what is the distance limitation with fiber cabling? So fiber cabling can run kilometers. So there's two types of fiber cabling. Again, we will discuss this later on when we deep dive into Ethernet. There's multi-mode and single mode. Single mode can run at longer distances than multi-mode. It can run, I think the maximum distance it can run is like 40 kilometers or something. Massive distances. So we're talking about, with Ethernet is only limited to 100 meters. Fiber cabling can easily run for 1 kilometer, 2 kilometers, 5 kilometers, etc. Very long distances. Yeah, so the single mode, which is longer distances than multi-mode. However, with multi-mode, I think the light moves around less as it travels down the actual fiber cabling. So with fiber cabling, it actually transmits and receives data by pulsing light, which is pretty cool. So now I know what you're saying. Okay, so when do we use fiber? When do we use Ethernet? Well, typically, you are going to be using fiber when you connect your network devices together, so as example, switches. So in this example, let's say that this is a university campus. We have building A and building B. Now we want these buildings to be part of the same network. However, there's an issue. Building A and building B, they're more than 100 meters apart. How do I connect the switch in building B to the switch in building A so that students in building B can communicate with students in building A and can access the same resources? The solution, we use a fiber cable. So we would run a fiber cable from building A to building B, from this switch in building A to this switch in building B, to connect these switches together, allowing communication across campus. And for any devices which are less than 100 meters away from our switch, we would just use Ethernet cabling. Now it's important to note that devices that you are going to connect your switch, such as laptops, computers, phones, cameras, etc., they will 99.9% of the time be 100 meters or less in distance away from the switch that you want to connect them to. Okay, usually we would use fiber cabling to connect our network devices like routers, switches, etc. if they're going to be more than 100 meters away. As an example, let's take an airport as an example. In an airport, where our switches are going to be placed within the airport, chances are the switches are going to be more than 100 meters away from each other. Now, to connect the switches together, to allow connectivity between devices in one switch and devices in another switch, because the switches are going to be 100 meters or more away from each other, we would use fiber cabling. So again, when to use fiber, when to use Ethernet, it just depends on how far the network device is away from each other. So how far the network devices are away from each other. But typically your laptops, your computers, they are going to be within the 100 meters distance from your switch. Usually you will be using fiber cabling to connect switches or routers in different buildings together, or if the switches or routers are more than 100 meters apart, which is what you would typically say. And it's also worth noting that a lot of the time, you can look on your computer, you can look on your laptop, it's not going to have a fiber port built into the computer, built into the laptop. Usually you are going to have an Ethernet port. Hence the reason why usually you are going to be less than 100 meters away from your network switch. Now let's have a look at a router. So a router, okay, let's go back in. Main function of a router, to get us from one network to another network, to get us out of our network. Now a router, as you can see, has actually got much less network ports than a switch. The reason being because it's only meant to connect to a few networks. If you think about it, each port is actually a different network. Each port would be connected to a different network range, essentially would be assigned a different IP address. If we go back to the switch, all of these ports are going to be on the same network. None of these ports are going to be having IP addresses at all. The switch itself will have one IP address, and that IP address is used to manage that switch. The ports themselves are all going to be on the same network. Okay. However, with the router, these ports, so this port over here is going to be on a different network to this port over here, and therefore they have to have IP addresses in different network ranges. Now, what are these metal plates here? So what a router allows you to do, it allows you to add modules, so we can add more ports to the router if need be. We could even add switch ports to the router, so the router can actually function as a small switch. We can actually have ports which are on the same network, which don't need to have IP addresses assigned to them. We could add what we call serial ports, which we would use for frame relay connections. Again, more about frame relay later on. But these metal plates here, they allow us to add more ports onto our router for whatever reason why we would need more ports to be added to our router. As you can see here, we've got the 3-pin, let's say, power plug that we would plug the power cable into, and we actually have a switch. Now it's important to know that I've never seen a switch with an actual power switch, with a switch that turns on and off. If you want to turn a switch off, yes, you need to unplug the power cable. Routers, on the other hand, I have seen routers with a power switch allowing you to turn it on and off. I don't know the reason why switches and routers, why a switch doesn't have a power switch and my router does. I'm not too sure why. But essentially that's what a router looks like. And as you can see at the front here, this is, so we didn't see this in the previous picture of a switch, but I don't know if I can zoom in actually, but essentially we are going to have additional ports on a router or on a switch on a wireless LAN controller. This is what we call the console port. Now the console port allows us to have a physical port that we can plug into to allow us to manage that switch locally. So when you first get a device, it's going to have no configuration on it. It's going to have no management IP address, no configuration on it, which will allow us to connect to that device remotely. As an example, a router or switch to connect to it remotely. When we first get a network device, we're going to have to set up from scratch. We would use what's called a console cable to actually physically plug into that device so that we could be at the device. So we'd have to physically be next to that device, physically be able to touch that device. We would run a console cable from our laptop, from our computer into that device so we can manage it locally, so we can manage it actually on site. This is very good because obviously if you for whatever reason lose connectivity to that device, you can always go to that device locally and connect to it locally to actually manage and configure it. Now we have a firewall. Now this is a much better picture actually. You can actually see the console port here. And the console port, like I said before, allows us to actually manage the device locally. So we need to actually physically be there, physically be able to touch that device to be able to manage it, via the console port. So like I said, a firewall before, this is an ASA 5505 series, pretty good home firewall, pretty good actually small business firewall as well. One which you can use for your lab. So which one do I have? Actually no, that's a wireless LAN controller. Forget about what I was going to say. So this 5505 ASA. Okay, now ASA stands for I think it's like Application Security Appliance or something. This is one of Cisco's firewalls that you can use to provide firewall services to your network. Now I'm pretty sure each of these ports is actually its own individual network. So these ports can actually be layer 2 or layer 3. Now, I know what you're saying. What's the difference between layer 2 and layer 3? So layer 2, it means that those ports are all part of the same network. Layer 3, it means those ports, individual ports, are going to be on different networks. So we can actually run our firewall in layer 2 mode where it doesn't have an IP address, where the ports don't have IP address, or we can run it in layer 3 mode where the ports actually are in their own network. Each port is in its own network. Each port needs to have an IP address in a different network. But that's what a firewall looks like. So it's got more ports than a router, but it's going to normally have less ports than a switch. And like the other devices, it's going to have a console port to allow us to manage it locally. Wireless access point. So wireless access point, as you can see, is actually a much prettier device than, let's say, the ASA firewall or the router, the switch. And the reason why, your wireless access point, those are the devices which are going to be the most visible. So you can look around as you walk around, let's say, an airport. Chances are you're going to see loads of devices like this up on the ceiling, up on the wall. Wireless access point is going to be mounted on a wall or on a ceiling, and it's going to radiate a RF signal so that we can connect wirelessly to a network. Now, a wireless access point is going to have a console port to allow you to manage the device locally if you need be. It's also going to have one Ethernet port and one AC/DC power port. Now, usually, wireless access points are going to use power over Ethernet. Now, what's power over Ethernet? So, without going into too much depth, power over Ethernet allows us to run an Ethernet cable from our switch into our wireless access point. And just before I go further, your switch has to support power over Ethernet. But what it allows us to do, allows us to deliver power to devices such as IP phones, access points, deliver power to those devices over an Ethernet cable. So we don't need to actually have a separate power cable plugged into this access point. We can plug in an Ethernet cable into this Ethernet port and deliver power over the Ethernet port so that we can power on this access point. And like I said before, your switch has to support this function. And so if this is a lightweight access point, we would literally just plug this in. This would then go and find its wireless LAN controller, and we would do all the configuration from the wireless LAN controller. If this was a autonomous AP, we would need to actually configure these devices manually, each device manually. We could do this from the console port, or we can actually do this from a web GUI. So I think when these devices power up, they're assigned just a default IP address of, let's say, 192.168.1. something. We can connect to it, so you can look, let's say, in the box, or you can research online. These access points are going to be assigned a default IP address, which will allow us to connect to the web GUI, allow us to manage it like that. So next device, wireless LAN controller. So this is a 2500 series wireless LAN controller. I've actually got 2504 wireless LAN controller, which I use for my wireless certification. A very good wireless LAN controller, very cheap as well. I think that cost me about £200 to £300, so it wasn't too much. The access points themselves cost me like £20 to £30 each. I think I had like 2 or 3. But a wireless LAN controller, this is what. This is 2500 series. Not all wireless LAN controllers are going to look like this, but they're going to look something like this. They're just going to be a square. Now I know what you're thinking. How come all these devices are rectangle? The reason being is so that you can mount them in a cabinet. So a lot of the time your devices are going to be mounted in a what we call, let's say, a cabinet in a rack, and so they have to be square in order for them to be mounted in this cabinet, in this rack, because racks, cabinets, they're square. So wireless LAN controller, this is what it looks like. Again, it's got these ports. Okay, these ports are going to be layer 2 ports. Okay, and if we wanted to, we've actually got power over Ethernet ports as well. So these ports are specifically PoE, power over Ethernet, so we can power devices like IP phones, cameras, access points over the Ethernet cable. And again, we have, like I said before, every network device has a console cable, so we can manage that device locally. Server. So the server was the last device that we looked at in our networks section, in a network devices section. Again, just to cast our minds back, a server is just a computer system offering a service to another computer. Servers are normally they're going to be, out of all the network devices, they'll probably be some of the most beefiest, some of the biggest, because they've got so many different hardware components in it and such powerful hardware, a lot of RAM, etc. But this is what a server would typically look like. Again, it's going to be a rectangle. It's going to have brackets on the side so you can mount it within a rack. On the back, it's going to have multiple fans that it can cool it. A lot of the time, these fans are going to be hot swappable. Now, what does that mean? That means that you can actually change the fans whilst the server's running, so you don't actually have to power it off. A lot of newer switches, a lot of more powerful switches will actually use the same feature as well, where you can actually swap out the power supply, swap out the fans, without actually having to turn the device off. Hence the name hot swappable. We're also going to have multiple network ports, so that we can essentially run multiple connections to the server, so we have more bandwidth to play with. Imagine that these are all 1 gig each. We can have 4 gigabits per second of data running to this server. We usually have like a VGA port, or let's say HDMI port, allowing us to connect a screen to our server if need be, so that we can manage the server locally in case we can't access it remotely. And that's everything. So this video is not going to be a very long video. It was just literally just to show you guys what these devices look like. On YouTube there are loads of videos which show you the inside of a data center, which will show you what these devices look like. I would say that I'd recommend that you watch those videos, because what I've done so far, I've just told you what these devices do. I've told you what the function is. I've shown you some static pictures, but it helps so much better if you see what these devices look like. If you see what these devices are like, the differences between these devices, where these devices are stored, it's going to help you so much more. Again, thank you for watching this video. If you want to see more like this, then please subscribe to my channel. Thank you very much.